humbled to be speaking for you. I have a great admiration for the job you do. You literally lay the foundation for the next generation in society. Anyway, a little bit about myself. I am actually a certified high school teacher. It's not on my CV, but it is in fact. As I was going through college and graduate school, I knew one thing with absolute certainty. I was never, ever going to be a teacher or a professor in my life. Didn't quite work out that way. Both of my parents were educators, and I was going to do something quote unquote useful in my life and go into industry. Well, here I am. Life took a 90-degree turn, and I ended up teaching and finding it, one of the most rewarding things one can do. And I'm sure you'll probably all agree with me that there's no bigger beauty than nurturing the human mind, and especially nurturing the human mind in thinking. So after I obtained my PhD and I had my high school teaching certificate, my father actually recommended I go for 1 year to do a postdoc in the US. I grew up in Europe. And I said, that's maybe a good idea. I already had a job lined up in industry. And so I called the company, Philips, and I said, is it okay if I do a 1 year postdoc in the US? And they said, sure, we'll keep your job open, and when you're done with your postdoc, you can come and take that job. So I went back to my father and said, where should I go for a postdoc? And he said, well, if you have a job, why not apply to some places like MIT, Harvard, Berkeley, Caltech? And I got an offer from Harvard for a postdoc, and what can I tell you? It's been a very long year. And after 2 years of course I'm no longer a postdoc, but that's okay. After 2 years of being a postdoc, I got appointed to be a assistant professor, which I accepted as an extension of my postdoc, and I still had in the back of my mind, I'm going to go back to Europe and going to work in industry. I just planned 2 weeks ahead. It might happen in the near future, I don't know. But essentially what I'm going to do here this morning with you is to sort of reflect a little bit on education and also give you a little bit of a story about my own evolution as an educator. And I thought I'd start with a little reflection. So what I would like you to do is to pull out a little piece of paper. You can pull out your device and have an electronic piece of paper. So I'm going to ask you to write down a few things for yourself. You won't have to reveal what you write down. It's pretty private information. But I do want you to write it down to commit yourself. So the first thing I want you to do is to think of something you're really good at. Something that you're proud of. Some kind of a quality. It could be knowledge. It could be, teaching. It could be speaking. It could be photography. It could be baking cakes. Anything. Ideally, I would like you to choose something that has been important in your professional life, but it's not essential. Just write down something you're proud of and something other people admire you for. Oh, when I think of, she's or he's good at that. Okay, I see everybody immediately writing down. That's great. We're all good at something, right? If you're good at many things, just pick one. Okay, who needs more time? And you don't need to write an essay. Just 2 words to jog your memory, because the next question is going to refer to whatever you wrote down. And again, you won't have to reveal it to anybody, so you can hide it from your neighbor. You don't have to be modest here. Okay, anybody need more time? Okay, now comes the hard question. How did you become good at whatever it is that you wrote down. What did you do to develop that skill, or, you know, gain that knowledge? It's hard, you know, because you probably learned it a long time ago. I see, actually, you know, the first question, everybody started writing right away. This one, there are a lot of people who are just thinking, how did I learn that? What did I do? And the reason is, of course, quite understandable. Right? If we are good at something, we tend to enjoy it. If you enjoy it, the learning happens automatically. You know that from the students who are intrinsically motivated in your course. They're more fun than those who are just taking the course because they have to. And the same is true for you. Okay, so dig back, way back in your memory, and ask yourself, how did I become good at it? And then write down 1 or 2 words. Who needs more time? Okay, so quick poll. How many of you wrote down lectures? Not by giving lectures, but listening to lectures. No hand goes up, right? And how are we teaching? This is how we're teaching. Actually, this is a picture of me as an assistant professor. It's a very old picture. It was taken BC, before computers. And, you know, I think you probably learned a lot of things sitting in a room like this. And trust me, if you step onto my campus now, I would say probably still 90-some% of the classes are like this. Most instructional spaces have forward-facing seats with the instructor at the focus, at the center of attention. Even though I would say it should really be focused on the student rather than the instructor. Probably most of you wrote down something that involves doing, like practicing or apprenticeship or trial and error on your little piece of paper. So, given that there's still a lot of teaching, especially in higher education, I know that in K-12 there have been dramatic changes over the past, 20 or so years. But I would say in post-secondary education, actually I found it really interesting when I drove here that this school is called secondary school. That's not a typical US term, right? So what grades?
It's outdated.
7 through 12.
7 through 12, okay, so it's very closely, that mirrors the way I was educated. You had an elementary school and then a secondary school. Yeah. Okay, sorry. I just, this was a question that was rattling around in my head as it was driving over here. So, in post-secondary education, I think still, in most parts in the US and all over the globe, that's what you find when, I was involved in the design of a new engineering building, a beautiful new engineering building we have, and I was in charge of the learning spaces. And when I saw the first plans by the architect, every single learning space was a room like that. Now, when I started teaching, as you can see in this picture, I started lecturing because I didn't know any better. I mean, after all, I had been taught that way, and I sort of naively thought, if I learned it this way, then that is how people learn. And I'm sure that my professors, when they started learning, they too were in a room like that, and they sort of mimicked their professors when they started teaching. And back another generation, and another generation, and another generation, all the way until this guy here. This is actually Emperor Heinrich VIII, Emperor of the Holy Roman Empire and of the German Kingdom, giving a guest lecture at the University of Bologna in the 1100s. It's an illustration from a 14th century manuscript, but it represents that guest lecture at the University of Bologna in the 1100s. Isn't it amazing? I mean, you see right away what this is. And the scene is not very different from that in any other lecture-based class. You can see the people in the front row paying attention, and then in the second row and in the back here, they look a little bit more bored. And you know, here in the rear corner, they're actually talking to each other. And then there's this person here in the front who has fallen asleep. Isn't the similarity with this picture of me teaching just uncanny, right? We no longer wear these robes that you saw in the previous image. But actually, you know what? We wear them at graduation to remind ourselves that we're steeped in medieval traditions. I would like you to tell me, to describe to me, with one or two words, one of which ideally is a verb, the activity that is taking place on the screen here. And the two verbs I do not want to hear are lecturing or learning. I want to find other words. So just blurt it out.
Listening.
Listening.
Passive.
Passive.
Writing.
Writing.
Sitting.
Sitting. Now, listening, sitting, that applies to them. I'm definitely neither sitting nor listening. Right? So, but we're both there, the students and I, in the same room at the same time. Is there something that describes sort of the connection between the two? So what happens between them and me?
Sleeping.
Sleep. Well, I hope I'm not sleeping there in front of the class. You know, I once heard somebody say, God, what was that saying again? Some people talk in their sleep. Lecturers talk while other people are sleeping. So thank you for saying that. But no, first of all, I'm not sleeping. Secondly, in my class, my students aren't sleeping. So what is it between them and me? What's going on there?
Delivering and receiving.
Delivering, receiving.
It's like a one-way.
We hope.
Like
There's
a
no
one-way
evidence
street.
of that on that picture. Interacting. So a two-way description, right? Delivering and receiving, and a one-way, two-way interacting and one delivering. But to interact requires things to go two ways, right? And you see that even in this space with you, just by virtue of the fact that you're all facing me, it's difficult to interact. Right? If I ask you a question, it takes a while for people to speak up. And let me tell you, with Harvard students, it's even worse. You know, I ask a question, it's complete silence. So there's no interaction. So it's really more one way from me to them. So what is it that is being transmitted or delivered here?
Information.
Knowledge.
I heard information, and what else?
Knowledge.
Knowledge, okay. So those are two different words, right? Knowledge and information. Now think about your own teaching. Can you actually transmit knowledge? Or think about your own learning. Think again about what you wrote down that you're really good at. Could you have learned that by just watching YouTube videos? Of course, there were probably no YouTube videos when you did your education, but imagine that was the case. Would you have been able to become as good at what you're doing by just listening to lectures or watching YouTube videos? No, I see quite a few people shake no. So I think knowledge is not really something that we can deliver or transmit. Knowledge is something that needs to be constructed in the brains of your students, that needs to be figured out by them. You cannot figure it out for them. No matter how clearly you articulate your thinking and your thoughts, unless they have this aha moment, oh, now I get it. They haven't really learned. So really, I think lectures come down to transmitting information. And maybe that that was something that was needed in the 1100s when, you know, Heinrich VIII was giving his guest lecture in Bologna, because there was no internet. In fact, there was not even printing of books. So the only way to transmit information from one generation to the other was to deliver it orally and to have people take notes. Now, I had no idea of any of this. Right? It's easy to talk in hindsight, but when I started teaching, and I was asked to teach the intro physics course for pre-medical students. These are not students who wanted to learn physics. They dreaded physics.
Yeah.
They dreaded physics, but they had to take physics because otherwise you can't get into medical school. So these are not the students you want to teach because they, you know, are not very positively predisposed to physics in the first place. In fact, the reason I was asked to teach that course as an assistant professor was because nobody else in the department wanted to teach that, so they thought, let's have Eric teach that course. And something amazing happened. The students actually liked my course. I got really high evaluations, you know, like 4.7 on a 5-point scale. And on top of that, you know, normally when physics is taught to pre-med, it's an algebra-based course, not a calculus-based course. Coming from Europe, this whole distinction between algebra-based and physics and calculus-based physics made no sense whatsoever to me. After all, you know, Newton's laws is calculus, right? Kinematics is calculus. So I thought, you know what, I'm just going to do a calculus-based course. And I could ask these students of mine some questions that I wasn't quite sure on exams, that I wasn't quite sure I could solve well. But you know, they did well. Did it well, they gave me high ratings. Obviously, I was doing the right thing. So there was this positive reinforcement. And very quickly, I started to believe, given the fact that most of my colleagues would get abysmal ratings when they taught this course, I very quickly started to believe I am the world's best physics teacher. That was such an illusion, let me tell you. It was a very pleasant illusion, but it was an illusion nonetheless. Now, you know, my students had actually rubbed this in my face, the fact that I was transferring information. Not quite in these words, but they'd rubbed it in my face. And I had ignored it because I basically didn't understand exactly where they were coming from. See, when I started teaching, as I told you a minute ago, I didn't ask myself, how am I going to teach? The first question that came up after I'd been told, Eric, you're going to teach Physics 11, was not how, but
what?
What, exactly. So I went to a colleague who had taught the course before, and that colleague told me, in this course in the past, we've used the book by Halliday and Resnick.
I used that one.
By the way? Yeah. Amazing, isn't it? I think because already by the time I started teaching, we were in the 6th or 7th or 8th edition, so it's just absolutely amazing. And my colleague told me something else, which, coming from Europe, struck me as rather strange. He said, be sure that at the beginning of the semester, the bookstore has enough copies of Halliday and Resnick in stock so that, you know, the students can buy a copy. Why would we buy a copy of the textbook? I mean, the instructor is presenting the book to us, so, you know, why spend the money on that? But anyway, I did as I was told. 2 weeks before the class started, I went to the Harvard Coop, which is our bookstore, and I said, be sure that by September 15th, you have 150 copies of Halliday and Resnick in stock. Okay, and I walked back to my office, and all of a sudden I thought, wait a minute. If the students have the book and I use the same book, then what point is there to come to class? I started to panic, you know, so I went to my colleague, I knocked on his door, and I said, you know, what I just told you, what am I going to do if the students have the same book as I have? And he said, oh, Eric, don't worry. There are lots of different physics textbooks, and he showed me on his shelf a whole collection of physics textbooks that he had. And you know, I started looking around, and then I found the perfect book. It was perfect for two reasons. One, it had a different approach than Halliday and Resnick, so at least I was not regurgitating the textbook that they were using. But that was not the important point. The important point was the book was out of print. So they couldn't get their hands on that book. So for each class, I would spend, you know, hours and hours preparing a lecture, and then in class, I would either, you know, project it on the overhead projector, remember this was BC, before computers, or I would write it on the board behind me. Now, since it was BC, it was also BI, before the internet, so there was no way of getting the notes to the students. I thought, you know, given that my lectures are different from the book, it would be good for the students to have a copy of my lecture notes. So before class ended, 10 minutes or so before, I would have one of my teaching assistants put big stacks of photocopied notes near the back exits of the lecture hall, so that as they walked out, they could pick up a copy of what I had lectured from. Now, why do you think that I had them out at the end of the class?
So you had to stick around.
So they had to stick around and listen to me, as if getting the words out of my mouth is essential. Isn't that, in a sense, admitting that we have a problem? Mm-hmm. I didn't realize it that way, but now that I think back of it, you know, I was probably fully aware of it already, you know, subconsciously. Anyway, students would pick up the notes, and you know what happened? At the end of that very first year of teaching, about half a dozen students wrote in the comment section of their end of semester evaluation. They would still give me high ratings, but in the comment section they would write, Professor Mazur lectures straight from his lecture notes. Hello? I mean, what was I supposed to do? You know, develop another set of lecture notes to lecture from that was different from the lecture notes I gave out to them? I mean, I thought, these are ungrateful students. But you know, they had a point. I was lecturing from my lecture notes. I was focusing on transferring information. And if they had read the book beforehand, they would have seen that the book was not that different from my lecture notes. I can't resist telling you another anecdote. This is another quote that I heard. The lecture is a process whereby the lecture notes of the instructor get transmitted to the notebooks of the students without passing through the brains of either. And that's more or less what was happening in my class. Anyway, given the positive feedback that I got, and again, the positive feedback consisted on good exam performance and high rating, this went on for many, many years. Until this, you know, sort of whole, you know, house of cards collapsed, and it became clear that it was just one big illusion. The lecture method is really the perfect way of putting sand in the eyes of people, because it gives the perfect illusion of learning. And it took a long time, like 7 or 8 years. I think after teaching for 7 years, I came across the force concept inventory. I presume that some of you know about the force concept inventory. Who has not heard of force concept? Because, okay, a few people haven't heard. So let me. So it's essentially a 30-question survey, conceptual survey of the concept of force, of Newtonian mechanics, essentially. But it asks the question all in words and referring to sort of more daily life type situations. I looked at that and I thought, oh, this is so simple, it's just too simple for my class. But then I saw the data and I saw, wow. And you know, it was developed by David Hessness at Arizona State University and tested in colleges and high schools in the Southwest, California, Arizona, you know, and so on. And there were no data yet about other parts of the country, and I thought there must be something really wrong in the Southwest there. You know, in my class at Harvard, they are going to ace these questions. Let me give you what turns out to be the hardest question on the force concept inventory. A heavy truck and a light car collide head-on on the highway. Is the force of the heavy truck on the light car larger than that of the light car on the heavy truck, equal to the small car exerts a larger force on the large truck than the other way around? And then there's another choice, which is, I find very amusing, is, you know, they're not exerting any force on each other, they are just in each other's way. So the way this survey was constructed was not by Hestenes and Halun, who's the other author, come up with these choices. They gave them as free response questions and then tabulated the most frequent wrong responses. This is one of them. Now, in spite of the fact that most students can recite Newton's laws, they turn out to have great difficulty with these questions. And as I told you, I thought that's not going to apply to my students. So, but I thought, you know, I'm very much evidence-based, so I thought rather than just making that assertion, my students will be fine, I am going to prove that my students are doing well. Well, that's when things began to unravel. Because hardly had the students started working on this quiz, I didn't want to scare them too much. I said, it's not going to impact your grade. It's not a test. It's just a quiz to test the efficacy of my own teaching. Hardly had this started, or one student raised her hand. And I walked over to her, and she looked at me and she said, Professor Mazur, how should I answer these questions? According to what you taught me,
Exactly.
or according to how
What I
I
think.
usually think about these things. I was so shocked. I didn't even understand the question. I didn't know how to answer it. Shouldn't those two things be the same? Anyway, at the end of the test, it was clear. My students could answer all these algebraic or calculus-based questions without any problem, but they really had no clue what they were doing. They did not have a coherent picture of the concept of force in their mind. And yeah, maybe you can cram and then pass the test by memorizing equations, hunting for equations, then putting the numbers into the equation, but does that really make you a better thinker? Does that really make you appreciate the beauty of science? Does that really advance society, right? I have an interesting term from some of my students. I teach a very different class from what I'm describing to you now, even from what I'm going to describe to you in the second part of my talk this morning. So I teach a completely project and team-based course where we have no lectures. I really miss lecturing. It's wonderful, so I'm really happy that you're giving me an opportunity to lecture to you. Because my class has no lectures, it has no exams, it has no classroom. They work in teams in different parts of the building. And it has no start and end time. I would always, you know, even though we had the first three, I would come to class, I would make my announcements and then say, okay, you can start working. Until one day I thought, when I go to my office, I don't have to wait for the president of the university to make his or her daily announcements and then say, okay, Eric, you can start working now. I start working when, you know, the people around me are ready to work. I said to myself, you know, shouldn't I treat the students the same way and give them the autonomy and also make them responsible to each other, right? So if the four of us are on a team and I always come late, doesn't bother me as the instructor, but the other students are going to be annoyed that that one person is late. Let me tell you, I've never looked back from the moment I made that transition. So anyway, long story short, you know, let's go back to 1990 or so. When I discovered that my students weren't really learning, I started thinking, you know, what should I do? And the The solution sort of presented itself serendipitously. All the good things that happened in my life were serendipitous. It's really true. So now what I essentially see as sort of the necessary steps of education are, one, transfer of information, right? If you don't transfer information, you can't learn. We all agree about that, right? But I think we live in an age where the transfer of information should no longer happen by lecturing, because we have many other good ways of transferring information. And also, this is not sufficient, right? Just getting it in the notebooks of the students is not enough. The students need to somehow assimilate that information, develop the mental models that permit them, or construct the knowledge, if you want, that permit them to apply what they've learned into a situation that they haven't seen before. I'm sure you've had many students say, come to you and say, we've never solved a problem like this before. You know what that is? That's an indication they haven't really learned. Sad as it may sound, but that's true. Because, you know, if they had seen a problem like this before, it would by definition no longer be a problem. Think about it, right? If you've seen a problem and solved it before, then it's at that moment it stops being a problem. And what we really want our students to do, you, yours, I, mine, society as a whole, is to be able to tackle the problems that nobody yet knows how to solve. But we sort of protect them from that.
Right.
Okay, so in the standard approach to teaching, the first step happens in class. And then the second part, making sense, having the aha moments, happens outside of class. And you know what? It worked for us, for you and me. Otherwise we wouldn't be sitting here, right? It worked for us. But most of our students are not like us. They're not going to be physics teachers. They have very different interests. They're not going to have the discipline or the intrinsic motivation or the curiosity to work on that second step on their own. They're not going to sit down, God, I don't understand this, you know, why, and then find somebody to help them resolve it. They're going to think, well, I'll just memorize this. Take a shortcut. So if you ask yourself, which of these two steps is harder, and that's essentially sort of the aha moment I had when I saw that my students weren't really learning, I think we would probably pretty quickly agree, it's the second part that is the hard problem. Yet I was spending all of my time on step one and leaving this to the students on their own. So that's when I came up with the idea, I should really focus on that. And back in 1991, long before the term the flipped classroom was coined, I said, okay, you know what? I'm going to throw this around. I'm going to do the transfer of information out of the class, and I'm going to work with the students on assimilating that information. So essentially, I told them, read my lecture notes before coming to class. Read the chapter in the book before coming to class. I didn't spend much time thinking about the implementation of that. I have since then, but you know, since this is the easy part, let's focus on the harder part, the second part. And you know, this is the serendipitous thing. It's not that I was sitting in my office thinking, what am I going to do to you know, help students assimilate it? Because essentially the answer was, teach by questioning rather than by telling. It's not that I was sitting in class thinking, in my office thinking, oh yeah, that's what I should. By the way, who was the first person to say that we should teach by questioning? Socrates, exactly, 2,000 years ago. And if I'd given this talk in Asia, they would have said Confucius, who also said, roughly at the same time, actually a little bit before Socrates, we should teach by questioning. Said it slightly differently, but it boils down to the same point. So already, you know, for millennia, we humans have known, you know, we should teach by questioning, not by telling. But it was not like that I was sitting in my office and I was thinking, what am I going to do? Oh, Socrates. No, not at all. It was very different. This is what happened. After I'd given the FCI to my students, they panicked. It was close to the end of the semester. The final exam was coming up. They saw their scores. They thought, how is this possible? I'm going to fail the final. So even though I told them this is not going to impact your grade, they said, we want to know what we got wrong. So I booked one of the large classrooms in our science center, the one you saw in the picture before. You know, by that time I had 250 students in my class, because the popularity of the class. And I booked it from 7 p.m. to 10 p.m. one evening to go through every single question. So I went through every single question and, you know, basically lectured to them about those questions. I remember I came to this question about the heavy truck and the light car, and I thought, this is easy, Newton's third law, right? So I made a free body diagram for the car on one side of the board, for the truck on the other side of the board, force of gravity, normal force up, and then the force of the truck on the car, and the car on the truck, and I turned around and I said, by Newton's third law, these two are equal. What more is there to explain about this? And I could see from the faces of my students that they were confused by that, because they had said the truck exerts a life. So they were confused by it. So I said, is there a question? They were so confused they could not articulate a question. So I thought, this is bad, you know. So maybe that they're confused by the fact that the forces are the same, but the effects are different because, you know, the truck is much heavier than the car, Newton's second law. So I erased the board, I started all over again, and now I brought in equations, and I brought in Newton's second law, and I showed that even though the accelerations were the same because of different mass, even though the forces were the same because of different mass, the effects, the acceleration were very different. I mean, literally, I gave the most brilliant explanation you could possibly imagine. Of course, I'd all done that with my back to them. It took maybe 8 minutes, and then I turned around. They looked even more confused. And I could still not articulate a good question. I didn't know what to do. I'd given my best twice, right? But I knew one thing. I knew that about half the class had given the right answer. So in a moment of despair, I said, why don't you discuss it with your neighbor? I don't know why I thought that, but I just tried it. And something happened I'd never seen in my classroom. Total, complete, utter chaos. Okay? They all forgot about me in front of the class. I could have walked out, nobody would have noticed. Okay? They were so engaged with each other that they forgot everything else. And what was even more surprising that was in 2 minutes, they had figured it out. I, the expert, had spent 10 minutes to explain to them in 2 different ways, unsuccessfully. And they figured out in 2 minutes. I thought, how is that possible? But imagine you have 2 students sitting next to each other, John and Mary. Mary has the right answer because she understands it. John, hasn't sorted out all of the problems in his head yet and gave the wrong answer. On average, Mary is more likely to convince John than the other way around, just the force of reasoning, right? But that's not the important point. The important point, which I realized then, was that Mary is more likely to convince John than Professor Mazur in front of the class. Why? Because she has only recently learned it. She still knows what the difficulties are that the beginning learner has. Whereas Professor Mazur learned it such a long time ago, I figured this out in high school, essentially, that he has forgotten how a beginning learner thinks about it. We, you and I, suffer from what Susan Ambrose, in her great book, How Learning Works, describes as the expert blind spot. Once you have had that aha moment, once it all clicks in your head, you can no longer imagine, the barriers that a beginning learner has. Anyway, so I saw that, I thought, that's how I should teach, by asking a question and have students discuss it with each other. So that's when I came up with the idea of peer instruction, which I didn't call peer instruction right away, because it was just because I had to submit a proposal to the NSF. I said, okay, I've got to trademark this. So I asked now, I don't lecture anymore in my classes. I teach by questioning. In fact, now my classes are partially based, so it's still more different. But I walk into the classroom, talk maybe a few minutes, I ask a question, and I give students time to think. It's almost as silent as in an exam. I don't want them to talk to each other. I want each of them to commit individually to an answer. And then I poll them.
Do you mind keeping it down a little bit, please?
I beg your pardon?
No, I'm trying to hear you over.
Oh, okay. So essentially, initially we did that with show of hands, and then eventually the clicker came around and other polling systems like Top Hat and you name it. But that's irrelevant. You can do it without any technology. And then I tell the students, now find a neighbor who has a different answer and try to convince that neighbor that you're right and he or she is wrong. I tell them, if your neighbor has the same answer, do not talk to that person, right? There's not much to talk about, right? And if the people all around you all have the same answer, don't take that to mean that you're right. Walk up to another part of the classroom and find somebody with a different answer, and then try to justify your answer. And then I poll them again, and if at that initial poll, that's what I tried to aim at, I wanted at the initial poll between 30 and 70% correct. Because if it's less than 30%, there are simply not enough students to teach the others. If it's 70%, they're going to get off task very quickly because there are going to be large pockets where everybody has the right, correct answer, and they'll be done right away. So the sweet spot is sort of between 30 and 70. And if you're there, then it is not unusual to go close to 100%, like 90% on the second poll. Doesn't always work, of course, but in general, you have large gains, because what happens is that during this discussion here, and also essentially I wrap up with an explanation. Ideally, that explanation comes from one of the students. Sometimes it comes from me. And then the cycle repeats until the class is over. And of course, the aha moments happen there. It's so, it's so amazing to walk around the classroom and listen in on these discussions, because in a sense, you get a window into the brains of your students. You just find out. I promise you, if you do this, you'll go, oh, that's what they're thinking. Because it reveals the thinking, which otherwise remains hidden inside their skulls, which we don't have access to. Right? So it reveals their thinking. And you will also see students who go, oh, you see that aha moment in front of you. I tell you, I took the plunge in the next semester with this. I haven't looked back. Do you want to try it? Yeah.
Can I ask you something real quick? Using the news Durgora example.
Yes.
Yeah. So you go through once and 35% of the kids have it right and they discuss. But what are you doing to see that percent that has it right aren't just mirroring what they already read, that it has to be equal and opposite versus a conceptual understanding? I mean, if you listen, you get that, but how do you do that?
Absolutely, really good question, thank you. I don't get that question very often, so I'm very grateful that you're asking that question. You see, one question by itself is not enough. You really need to have a set of questions where you attack a certain concept from different angles, so to speak, right? You have to see if it's consistently right rather than, occasionally right. And in different settings where they might not just recognize the question. If you look at the forced concept inventory, you'll see, and that's what convinced me that I had a real problem. You'll see that the third law comes in at least 3 or 4 times in different settings, right? And you'll see students who consistently get it wrong, because they always think the heavier object exerts a larger force on the lighter one. And then you see some students who occasionally get it right, but don't recognize every situation as a third law problem. And then you see some, of course, who blow, who will get every single question correct. So I think it's essential, right? So we're going to do one example, I hope. Do you want to try it?
Yeah.
Okay, good. So I'm going to make you're going to be my students, and we'll try it with one question. But it's only one question, right? So it's sort of a limited view of how a real class would be. So I'd asked Rob to distribute some readings on Archimedes' principle. Did you all do that? I'm kidding. I'm kidding. But you know, since you didn't read beforehand, I'll need to lecture for just a moment. So we'll do a question on it. How many of you teach fluids? Okay, so it's not universal in the curriculum.
No. I used to.
Okay. Well, but this is old stuff, right? I mean, you remember Archimedes was a philosopher, a Greek philosopher who lived in Syracuse. Not Syracuse, New York. Syracuse in Sicily. And at the time, the Greek were dealing with a major problem that a lot of coins, gold coins, were counterfeit. And they were made from another metal, but covered with a very thin layer of gold. And it is said that one day Archimedes was taking a bath, and as he put his body in the water, he noticed the level of the water go up. And he said, that's what we should do. He said, Eureka, which is Greek for I found it. And he was so excited that he jumped out of the bathtub and said to have run around naked through the streets of Syracuse. I don't know how much of that is true, but that's so anyway, so Archimedes' principle says that an object submerged either fully or partially in a fluid, the word fluid really means gas or liquid, but we'll talk about liquids here. So you can substitute liquid for fluid. Experiences an upward buoyant force, the magnitude of which is equal to the magnitude of the force of gravity exerted on the fluid displaced by the object. That's how he sort of formulated, maybe not quite in these words, and it was of course in Greek rather than in English, but that was the whole idea. That's the whole concept there. So let's say you have a boat illustrated on the left there, floating in water, even though metal is heavier than water, the average density of that boat is lower. Then essentially the volume of displaced fluid, let me use the pointer so that people on the other side can see too, the volume of displaced fluid is equal to the volume of the submerged portion of the object. So this is the ship, and the water within this dashed line is the volume of the submerged portion of the object. We know that the displaced water is not sinking, right? Even though it's being pulled down by the earth, by the force of gravity. So it must be held up by an equal force, right? If you draw a free body diagram for that water, the force up is the same as the force down. But the water around that dot, on the outside of the dashed line, doesn't care whether it's water or a ship there, and therefore, if there's a ship floating there, the upward force must be equal to the displacement. It's so clever, right? And that without the notation and the whole body of knowledge that we have now, thousands of years ago, pretty impressive. Any questions? Before I ask my question. Okay, good. Oh, great. I knew it. I'm a great lecturer. Thank you so much for reaffirming that. Okay, so let's establish some ground rules here. So I'm going to ask you a question. I want you to think about it alone. If I see you start talking to your neighbor, out of fairness to everybody in this room, I will ask you to stand up and tell everybody in the room what you just told your neighbor. My students do that. So I'm going to give you time to think. There's no pressure here, although we do want to finish this at some point. So, and then you will select an answer. After you've selected an answer, when I tell you to, I want you to check in with your neighbors. If they have the same answer, do not talk to them, okay? Say thank you and find somebody. If you need to walk out, to another corner, fine, no problem. But you need to find somebody with a different answer. And then do your best to try to convince that person that you're right and or he or she is wrong. Instructions clear? Great, I love it. The way we're going to do the polling, because we're doing polling, is using a really great method. I'm going to ask you to pick an answer, and then there'll be, I think, 3 answers. And so you pick either answer 1, answer 2, answer 3. And then I'll count, and at the count of 3, you need to put your hand on your chest showing your choice. So 1, 2, or 3. I mean, if you want to use other fingers, that's fine. It's up to you. But the number of fingers needs to correspond to the choice. If you do not put your hand on your chest, indicating a choice, I'm going to ask you to stand up and tell the whole room what your choice is. I tell that to my students too. Oh yeah, instructions clear? Yes. Okay, great. So here we go. Oh, I forgot to illustrate what the displaced water is. I had an extra slide here. Okay. So, a boat carrying a large boulder is floating on a small pond. The boulder is thrown overboard and sinks to the bottom of the pond. Right? So it starts in the boat and it ends at the bottom of the pond. Ooh. After the boulder sinks to the bottom of the pond, the level of the water in the pond is 1. So it goes from the boat into the pond. Higher than it was before the boulder was thrown overboard. 2, the same as. 3, lower than. There are no other choices possible. And don't feel under pressure, right? I mean, your salary won't be affected by this. This is not high stakes or anything. And I mean, it's being recorded, but I'm the one being recorded, not you, so. Okay, who still wants more time? So if you have not made up your mind yet, you're still thinking, it's 1, no, it's 3, whatever, then just make it a game. But pick an answer, okay? So at the count of 3, all together, and remember, if you don't put your hand on your chest, I'm going to pick on you. 1, 2, and 3. Keep it there for a moment. Wow, 1s, 2s, 3s, fantastic. You have a complete distribution of this is terrific. Go ahead, find somebody who has a different answer.
I printed this one thing. Okay, so I might be like forgetting all this. I think I remember the answer. So I was thinking that when the ball was in the bowl, the point was holding up the weight of the boat and the ball, and the point So my thought process is I need rock that is more dense than water. The rock is on the boat. Basically, the weight of the amount of water you would need to float the rock would be a larger volume than the volume of the rock itself. So when the rock is on the boat, the whole of the boat would have to displace a volume of water that is greater in volume than the volume of the rock. So then when the rock goes to the bottom, the rock has a smaller volume and the displaced water is more now.
And that volume of water
has to be more than volume.
I have yet to encounter, right? I mean, I started doing this 30 years ago, so I've spoken about this a lot. Each year I think, okay, I'm never going to talk about pre-instruction anymore, and I get invited again. Thank you, Rob. And I get all excited again, because it's just wonderful to see the excitement, and I've yet to find an environment where that doesn't work. We know it works because it works with toddlers, right? I mean, they wouldn't let that go until they really go, aha, I get it. So, you know, before I tell you the answer, let's dig a little bit deeper here. What happened here? I asked you the question, you thought about the question, and then I had you make a commitment, right? I had you make a commitment by voting. 1, 2, or 3. That's the first time. You made a commitment. Then I had you externalize your answer. Not to me in public, but in an environment that's completely safe, namely the people around you. And what was amazing, I walked around, you probably didn't see me walk around, was that you all, while you were talking, moved away from the answer to how do you get to that answer. It's not just the fact the water goes up or goes down or stays the same. It was, why is it that it does that? Many of you were gesticulating. It was amazing, just to look at the gesticulation of everybody. And again, that's true everywhere, okay? I've done this, everywhere. But the most important part is this. You became emotionally invested in the
Yeah, you do.
If I were to tell you now, oh my God, I need to go, bye, you know, and leave here, you'd come running after me in the parking lot to ask me, you know, what is the answer? Well, I'll tell you something, the answer doesn't matter because I've already made my point. I made my point about how, because I see a lot of disappointment. The point is not whether the water goes up, down, or stays the same. The point is, it's just absolutely fabulous how you can capture the imagination of the human mind. Right? It's beautiful in a sense. So, before I tell you the answer, we have to finish this process. Remember, question, think, poll, discuss. That's where we are now. Although I'm giving you a little, you know, a little bit of sign when it goes, and then poll again, and then explain. So, before we go to the explanation, you need to answer this question again. What do you now believe to be the right answer? If you have not changed your mind, you're going to have the exact same as you had before. If you have changed your mind, indicate what you now believe to be the right answer. At the count of 3. 1, 2, and 3. Why don't you all raise your hand at once? Don't change your fingers. Raise it and keep the same fingers up. 2, 3, 1, 1 there. I thought it was a good lecture, but you know, you should really have done your reading before. No, you made another really important point. Because by the way you voted here, you told me, or you've been implicitly telling me, Eric, your lecturing sucks. Which is actually exactly the point I wanted to make, right? I mean, it's hard to get things just by quickly listening to it on a Saturday morning when you're really not really prepared to work. The right answer is, wow, look at that. Everybody's looking at me. There's not one person looking down or tweeting or texting or whatever. Can I have a drum roll? The right question is number 3.
You're smart.
Hey, and should I tell you something? there were very few threes the first time around, and you saw how many threes there were the second time around. Okay, now let me tell you, this is not an easy question for most people. If you try to solve this with equations, you probably need about half an hour, right? Because you need to figure out the notation, what you mean, and so on. You get completely, you know. At Caltech, at the qualifying exam for physics majors, you know, like 20, 30 years ago, you used this question, actually, and many people get, many of my colleagues get it wrong, actually, this question. So I don't want you, in the middle of the night tonight, lie awake in bed about this.
No, that is me. Yeah.
So let me take a little bit of time to explain this so that you don't lose sleep tonight, even though it's not, my talk is not about this, right? So we start with the rock in the boat, right? So let's next imagine that we take the rock out of the boat. Does the level of the water go up or go down?
Goes down.
It goes down. Why does it go down?
Displace less water.
Because, you know, nobody is pushing that boat down, displacing the water up. Very good. So we all agree on that? Okay. So then we put the rock in the water. Will the level of the water go up or down between the middle step and the last step?
Up.
Up, because now the rock is taking volume in the water. Okay, so how much volume is it taking all the way on the right there? The volume of the rock. Very good. How much is it displacing on the far right?
The volume of the weight into the mass of the rock.
That's a lot of words, right? I totally agree. It's an amount of water that weighs as much as the rock. Is that more, has that a bigger volume of water? It's a bigger volume of water, yeah. So we have to look here. Here the displaced is equal to the weight of the rock, and there is equal to the volume of the rock. Suppose that we didn't have a rock. We had a pea-sized material from a neutron star, incredibly heavy. Okay, we put it in the boat, pushes the boat down, the water goes up. We take it out, the water goes back to, you know, just where it is with the empty boat. Put it on the side, boom, in the water, what happens? Nothing, it's just a pea, right? So there you see the extreme case that helps you read something. You remember the answer, right? And probably, how many of you had an aha moment and changed your vote from something to 3 while you were talking? Raise your hand. Well, you keep it up for a moment. I just want to see how many. You had your hand up. So see that just one question and there's aha moments. Even for us, right?
Yeah.
And I have aha moments when I teach this way because, you know, I figure out, oh, I haven't completely, you know, figured it out in my own head. Or I hear a student give an explanation, wow, I wish I had thought about this. I've never thought about this way of thinking about it. And it's a win-win situation, right? There were a number of you who had 3 the first time around, and probably many of the people who had 3 the first time around had it for a good reason, because they had the right way of thinking. But it's not that they were just wasting their time explaining it to people who did not understand. It's a win-win. Because as you all know, the person who learns the most in any classroom is the teacher, right? So you have 2 students teaching one another. The student who is teaching the other reinforces her or his own knowledge. And some of you may have experienced that right now. Okay, I need to wrap up here. But 2 points worth noting. My clear lecture was not that clear, right? It may have sounded clear. There was not a single question afterwards. There's nobody who asked me about Archimedes' principle. So, but it wasn't very good because a very small minority, only very close to, you know, a third, got the right answer the first time around. And the discussion promoted these aha moments, you know, these wonderful moments that give so much satisfaction to everybody, right? The person who explains and the person who gets it. And, you know, as one of my students said, is you figure it out really for life. You don't figure it out just to pass the exam. Once it sticks, it sticks. Okay, so back to peer instruction. You know, this is where the aha takes place, but that's not good enough. I want to show you that over the many, many years, not just in my class, many classes, many subjects, found increase a very big gain. This is the normalized gain for the FCI in my class, averaged over 10 years. Averaged over 2 years for lecturing, and then 10 years of peer instruction. It actually tripled the normalized gain. Okay? Tripled the normalized gain is if you go between the average class score at the beginning of the term, and then you see what percentage to 100%, because you really want to get your students to 100%, how you close that gap, right? Which is bigger for students who score lower at the beginning of the term than those who score higher at the term. And that's it's not like a 20% increase, no, it's a 200% increase, right? It's 3 times as big. And also better retention, as I said. Once you figure it out, you really figure it out for life. Even if you forget the answer, you've increased your confidence in being able to figure it out again. What psychologists call self-efficacy. You raise the self-efficacy in the subject. So what I want to leave you with is this. Education is not just about transferring information. It's also not about getting students to do what we can do. I always thought that was the case, right? When you teach, you want to teach students to be able to do what you do. I think we need to aim higher. I want my students to stand on my shoulders and solve problems I cannot yet solve. Right? We want the next generation to solve the problems that this generation cannot solve, and you only have to look at the news for 30 seconds to see that we have a lot of problems to solve. And just teaching people to do what we do, it's not good enough. And I think the best way to get people there is really, you know, to actively engage them, to have this social interaction that you experience here in the class. So I want to leave you with that. I want to thank you again. Thank you, Rob, for this opportunity. I have the slides uploaded at that URL. So if you're interested in downloading them, you can get them there. And it's being recorded, so you can refer colleagues who did not see it. I presume you'll post it somewhere. I don't do the recording. I don't handle the recording. But you can... if you want some of your colleagues who are not here to see it, you can have them see it there. Thank you so much for your attention.
That was wonderful. Thank you very much. I really enjoyed that.
I was going to say something, but no.
We have some questions.
Oh, I just have one quick question. So we had gotten the book, we were doing like a book club, and it came with the discs, like the floppy discs. So like I didn't know if there
I used to
there was
have
a
them.
site anywhere where we could get access to the
Yes,
questions. Like
yes,
digital.
yeah. Email me.
Oh, okay.
Mazur at harvard.edu.
Okay.
And I'll send you the file.
I got a question.
Okay.
For what instance, if it wasn't a rock, for
At
what,
least it was not a floppy disk that was in there.
They was. They had the floppy disks. Our colleague asked us if we could get one autographed.
right.
He never sold one. But.
For what instance, because I put number 2, would it be number 2? Would it be a volume of water that you threw over?
Very good question. Do you see how it captures the mind? It's not about question pedagogy. So for what case would it be, you know, at the same level? Not a rock, unless it's a rock that is neutrally buoyant in the water. I don't know if they...
Would it be a volume of water, that thing?
A volume of water would definitely do it, but it would, if there's a volume of any material that is completely neutrally buoyant in water.
Okay.
But your guy sinks.
Yeah, that's good.
So, right, part of your process is the object sinks.
If it sinks, the density is, yeah. Hey, we're done with that question, okay? We're done with that question.
I love it.
If you could teach us how to do that whistle, that would be the most
Please,
valuable.
please.
I could teach how to do that whistle.
Please, get it going. You know, I